It is kind of cruel and shallow money trenched through the heart of the journalism industry, a long plastic hallway where thieves and pimps run free and good men die like dogs. Our physiology should be optimized to the diet that we have experienced during the evolutionary past. And today we are going to take a deep dive into that evolutionary past. What did we actually eat? How we actually evolved? To understand this, let us look at the expensive tissue hypothesis by Leslie C. Alo. This paper had a hard time getting published, but today it is one of the renowned papers. It refers the brain to be the most expensive tissue calorie wise. This hypothesis is based on the work of Professor Max Kleiber, who is the writer of The Fire of the Life. He proved that there is a direct correlation between the mass of the animal and the metabolic rate. And he came up with this particular line, which is called Kleiber's law. As you can see, there's a straight line which shows direct correlation between the heat production, which is the metabolic rate, and the mass of the animal. Now even human beings fall on this particular line. So basically, when you know this, you will be able to find out how much calories does the brain consume, how much calories does individual parts of the body consume. Now if I take the example of a 65 kg human being of that time, his expected calorie expenditure of the body parts would look like this. However, the observed readings were something else. So in human beings, they observed that brain size had to get bigger and the gut size had to get smaller in order to fit them onto that Kleiber's line, because they were constrained by that Kleiber's law. Every mammal falls on that Kleiber's line. Now if you look at the gut size of an ape and a human being in the middle, if you see, human being has a smaller gut. And if you look at Australopithecine and Homo sapiens has a smaller gut. Now look at the gut of chimpanzees and gorilla, they have a bigger gut in comparison to a true hunter-gatherer of that time. So basically they ate a lot of plants to support that much calories, they had bigger guts. So the expensive tissue hypothesis proposes that we didn't evolve to eat meat, we evolved because we ate meat. Our expensive tissue, which is our brain, had to get bigger, and the diets of that time can be seen using stable isotope analysis. What is stable isotope? Basically, they look at the stable isotopes like carbon 12, 13, 14 is basically decays, nitrogen 14, nitrogen 15. These are stable isotopes that is absorbed by the bone of the animal. And now if we look at the stable isotope of Neanderthals per se, we can look at the skull of and the bone density, and we can find out that what kind of diet they actually ate. And if so, basically delta 15n tells you the carnivory story about the Homo sapiens. When you look at the delta n ratio of a herbivore and then a baboon and then a lion, you will find the increased concentration. And when you look the same in the Neanderthals, the delta n ratio is way higher, which shows that they were super carnivores and we evolved at that time. Now if you look at the ancient Egypt diet, basically it was consistently bread, based on bread. And if you just look at the ancient Egyptian pictures, they just have boobs and bellies all over the place. If you look at any of their statues, it's boobs and bellies. Now that's how we have evolved. But there was a species, A. robustus. A. robustus actually met a dead end because they turned vegetarian.